Hello everyone, my name is Mika Järvinen. I come from Aalto University. I'm an associate professor there. The topic of my lecture series is transition to renewable energy. I will discuss wind power, solar energy, principles of them both. Then I will discuss the requirement of energy storage in the case of intermittent renewables. It is required to have storage. And finally, I will then discuss topics related to green energy transition within planetary boundaries. But who am I? I have been as a professor at Aalto since 2012 with different topics. I have studied, for example, combustion of black liquor by modeling. I have worked with steel industry developing process models for them. I have studied supercritical water gasification of biomass. And also I work with different renewable energy technologies, including wind and solar. And also very important in decarbonization is how we can utilize heat pumps for CO2-free heating. Also in my research and also in teaching, I work with the utilization of waste, and especially waste plastics, waste biomass via combustion and gasification. And also I work with hydrogen-based energy carriers and CO2 capture. CO2 utilization and storage are also in the focus of my research. And what is the idea of these 5 video lectures, short lectures? We will first analyze technical performance of wind turbines and solar panels in power generation. We will then discuss capacity factors and how much a certain renewable energy system can produce power at different locations in the Earth. And then discuss the requirement for energy storage system, and finally discuss the planetary boundaries concept and how it's related to the green energy transition. And also a bit warning, I was brave enough to put some simple and practical examples of integration and derivation also on the material. Before we start on real topics, just a short introduction. This is a very famous or well-known diagram done by Perez et al. And what last updated 2015. The annual energy consumption in the world is on the left-hand side, you'll see the world energy use, which is 16 terawatt years, that small sphere. And it's clear from first look that solar energy is far the most largest resource available. We have also the finite resources here on the right-hand side, including coal and also all other fossil sources. But then after solar, of course, wind is a big potential energy source. And then also in the final solution, when we end up in using fully renewable system, we need a combination of many of these. There is not a single solution what we can utilize. Few words on some concepts before we go into deeper. So power and energy, it's very important to understand these in detail. Power tells us the rate at which work is done. So the unit is joules per second or watt, kilowatt, megawatt, and so on. And energy is the integral of the power with respect to time between two time steps, or two times. And unit is joule or watt hour, kilowatt, megawatt hour, and so on. And here are the mathematical expressions of those. Maybe you have studied or you have been doing this during your studies, but this is a very practical example on those derivation and integration. Remember also unit conversions. Very important not to, for example, confuse megawatt hours with megajoules. Take care that you don't mix these together. Thanks for listening to this introduction. If there are any questions, I'm happy to answer. Just send me email. I try to answer as soon as possible. Thank you.